Hey GeoData folks, so we are starting Unit 5 today. So we're going to do Investigation 1, Lesson 1 today. So we're going to start with the concept development of Lesson 1, okay? And we're talking about circles. This unit is all about circles. So circle, the definition of a circle is a locus of points, a group of points that are the same distance from a given point called the center. So what we have on this page is a circle that is centered at the origin. And if you remember, the origin is the point 0, 0. And this is going to be the set of all points that have a radius of 6. That means they are 6 units away. So they are 6 units away from the center, which is the origin 0, 0. Okay, so here we have an XY coordinate plane, right? This is the x-axis, this is the y-axis, and here's the origin. Here's point 0, 0. And I already penciled in the circle, but these are the points. This point is 6 units away from the circle center. This point is 6 units away from the center. This is 6 units away. This is 6 units away. And in fact, every point along this circle is exactly 6 units away from the center. All right, so if we wanted to check to make sure that all of these points were exactly 6 units away, say I wanted to do this point right here. All I would need to do to calculate that distance from the center, and this was in the pre-assessment, in the readiness assessment, if you remember, I would just construct a right triangle, right, using the grid lines or parallel to the grid lines. And what I have here is a leg, and here's a leg. And the hypotenuse is going to be the side that goes from the center out to one point on the circle, okay? So we can actually write the equation that describes all the points on the circle, because we know that if we take the distance from 0 to x, so that distance would be the x value, and we square it, and we add to that this length here, which would be the y value of this point, and we square it, we know that has to equal the length of the hypotenuse squared. And in this case, didn't we say that that hypotenuse has to be 6 units long? So that would be the equation that describes this round circle, where all the points are 6 units away from the origin. Every single point along that circle would fit that equation, okay? So another example might be, well, what if we had a circle? The center is at the origin 0, 0, but the radius is only 1 unit. Well, in that case, the equation would be x squared plus y squared equals 1 squared, or x squared plus y squared equals 1. All right, so what if we didn't have the information about the center and the radius, but we knew this was the equation? Well, x squared plus y squared equals, that's going to be the radius squared. That's going to be the distance from the center squared. So the radius is going to be 7, because 7 squared is 49. Right? So what if we knew the circle had a center at 0, 0, the origin, and the radius was r? We don't know what it is, it's r. Well, the distance from the origin to the x value squared plus the distance from the origin to the y value squared is going to equal the distance of the radius squared. And that's the basic equation for a circle with the center at 0, 0. So a quick reminder, is a circle a function? Do you remember what the definition of a function is? Put your algebra hats on. Do you remember a function had a basic rule that if you knew what x was, there could only be one y that goes with that x. If you have an input, you have to know where the output goes. You can't have one input value go to two different places for the output. And look at what happens with a circle. If I knew that my x was, say, -4, do I know what the y value is for this function? Well, it could be up here. Or if x is -4, this could be the y value down here. So for one value of x, there's two different points with two different y values. So no, it is not a function. It's never a function because many of the x values have more than one y. Right? And so that fails the test for being a function. All right. So let's continue thinking about this equation of a circle here. So on the next page, let's say we have, and we're going to be working with these points. They've given us 5 different points here, A, B, C, D, and E. And we're going to calculate the distance of that point from the origin. So in every case, we're doing a squared plus b squared equals c squared. And then we're square rooting it to get the c, right? To get the distance of that length. So what we're basically doing is saying that we have some point from the origin, right? And we're going to take this x value and we're going to square it. And we're going to take this y value and square it. And that's going to equal this squared, which is why we square root it, okay? So this point 2, 3, to find out how far that is away from 0, 0, well, the x value, it's going to be 2 units. So we have to square the 2. Plus the y value says it's going to be 3 units away. And then when we add those together, we have to square root the whole total. And if I square root 2 squared plus 3 squared, that's 4 plus 9. And the square root of 13 is 3.6. So the question is that greater or less than or equal to 5? Well, 3.6 is definitely less than, right? What if the point B was at the coordinates -4, 4? Well, -4 is 4 units away from 0. 4 is also 4 units away from 0. We square them and add them. And square root the total, and that's 16 plus 16, which is 32. And the square root of 32 is 5.7. Okay? 3 and -4 are the x and the y. Well, 3 squared is 9. -4 is 4 units away from the 0, right? -4, say down here is -4. That's 4 units away, right? Square them, add them, square root the total. Well, you know what? 9 and 16 is 25. So the square root of 25 is 5. Let's fill in the second column. 5.7, is that more, less, or equal to 5? 5.7 is more than 5, greater than 5. 5 is equal to 5. Okay, how about 1 and 5? 1 squared plus 5 squared, that's going to be 1 plus 25 is 26. And the square root of that is 5.1. 1. It's a little bit more, a little bit greater. And the last one, 4 squared. Negative 1 squared is the same as 1 squared. 16 and 1 is 17, and the square root of 17 is 4.1, which is less than 5. And you'll see why we're doing this. Let's plot these points on this circle here. So here's a circle with radius of 5. You can see how all the points are 5 units away from the center. Here's the center 0, 0, right? So look at where these points fall. 2, 3. 2, 3. That's 0.23 right there. See how it's inside the circle? The distance was less than 5. That means that point is not 5 units away. It's inside the circle. It's less than 5 units away, so it's inside. Look what happens with this one. Negative 4, 4. Negative 4, 4. That's up here. Well, we figured out that negative 4, 4 was 5.7 units away from the circle. So 5 units would be here. 5.7 is outside the circle, right? It's more than 5 units away from the origin, so it's outside the circle. 0.3, negative 4. Look at that. It's exactly on the circle. It's exactly 5 units away from the origin, and it's exactly on the circle. 0.15, where do you think that's going to be? 5.1. It's a little bit greater than 5. So where does that go? 1, 5 is just outside the circle, right? It's not much outside, but it's a little bit outside. It's a little bit more than 5 for a distance. And the last one, 4, negative 1. Whoops, positive 4, negative 1. That's right here. And that's inside the circle because the distance is less than 5 from the origin. Whoops, this one I didn't mark. This was 3, negative 4. Okay? So you can see for that circle, the radius was 5. So you can see when you have a point with an x and a y coordinate, and the center of the circle is at 0, 0, the origin, if you take your x squared plus your y squared, and you square root it, and you may recall that is the formula for distance that you learned back in algebra. If that number is less than the radius, then point xy is what? If it's less than the radius, it's going to be inside the circle. Right? Oops, let me fill these in. This was outside because it was greater, and this was inside because it was less. So what happens if the square root of x squared plus y squared is greater than the radius? Then what happened to it? What happened when it was greater than? It was outside, right? These guys, they were outside. So in that case, point xy lies outside the circle. And when is the point on the circle itself? What makes the point be exactly lying on the circle? That only happens when the square root of x squared plus y squared is exactly equal to the radius. Okay? So if the square root of x squared plus y squared equals the radius, then point xy lies on the circle. Okay? So that's enough for the first lesson. We're going to continue doing more with this in the the next coming lessons. So that's all for today. Bye, guys.